Before getting into any of the detail sections, I'd like to give an overview of information analysis. In this section, we'll cover the definition of an information model, two types of information models, components of an information specification, definition and sample of an entity specification, definition and sample of a relationship specification, definition and sample of a data element specification, and progressive information modeling. We're going to create an information model along with its supporting specifications. So first, the definition of an information model. An information model is a conceptual model showing entities, metadata groupings, and the relationships between any two or more entities needed to support an organization's processing. In the 1970s and 80s, a lot of authors proposed various models for depicting an organization's data needs. I'm going to show the symbology of two of the most popular here, and then after this section, I'm going to concentrate on one of the models. On the left here is a table describing what we model for stored data, and next to them are their associated symbols using Chen-style symbols and another common set of symbols. Peter Chen of MIT wrote a seminal paper titled The Entity Relationship Model Towards a Unified View of Data, printed in the Association of Computing Machinery in 1976. The top two rows of the table show entities and relationships, and the lower three rows show what's known as cardinality of relationships. Entities are things we wish to keep information about in the organization, and relationships are association between those things. Without getting into too much detail here, I want to point out that to me the notion of an entity is a reusable package of data elements. Just like we have reusable apps and routines, modules that can be reused across many systems, we need reusable packets of data that can be used in many processes. In other words, we want data that belongs to the organization overall and not to one specific job or specific system. I will describe these symbols in more detail in a later section. Please note that there are other methodologies that use different symbols than the ones shown here. I prefer to use the symbols of a Chen-style entity relationship diagram for my main modeling tool of information analysis in this tutorial. I've been teaching information analysis for many years, and I've seen new authors bring in their versions of these symbols, but try not to get adamant about which is the correct set of symbols to use in information analysis. Just make sure it's constant within an organization, therefore making it readable to all those who need to interface with the model. Information models also show the cardinality of relationships indicated by the number 1 and the letter N in the Chen-style diagram, and a line with or without what's known as crow's feet on the relationship line in the other symbol set I've shown. Cardinality is the occurrences of entities to other entities. As an example of cardinality, as you take this tutorial, we have one student with one teacher. That's a one-to-one relationship. This relationship could be called a tutoring relationship. However, when I conduct a live seminar, the cardinality between the entities changes. There is one teacher with many students, a one-to-n relationship, n meaning many. This relationship could be called a teaching relationship. Here I'm going to show just two sample information models using the different symbols. Remember, there are other sets of symbols. First, here's a generic example of a Chen-style diagram using the symbols names on themselves. It shows two entities in a binary relationship and three entities in an n-ary relationship, meaning more than two entities involved in the relationship. Using a package delivery service entities and their relationships, we might see the partial example on the right. It shows that a service center is in a binary employing relationship with many service agents. It also shows that a customer is in an n-ary delivery relationship with many packages and one service agent. On the lower left, we see the equivalent generic example using other symbols, and on the right, the package service example showing the same result but using just binary relationships. It shows a binary relationship where a service center employs many service agents, and a service agent is assigned to one service center. Also, a service agent handles many packages, and a package is collected by one service agent. It also shows that a package belongs to one customer. and a customer sends many packages. Note I've not tried to exactly match the generic models to the actual examples in the overview of the symbols. I'll show better examples of the symbols and describe them in more detail in a later section. Both models depict the same information requirements, but the Chen model has the ability to show a three-way relationship. The deliverable from information analysis is a Business Information Specification, the components of which are an information model, such as a partial entity relationship diagram shown from our previous example, and a set of support specifications for entities depicted on the information model, and relationships depicted on the information model, and data elements describing the content of each entity. Again, for the benefit of those folks who've taken my business process analysis tutorials, the data elements will be the same as the ones in the data flows in and out of stores on the business process model. Let me briefly define an entity and what we gather in a specification for it. First, a definition. An entity is a named, significant, and permanent component of the business about which information must be held. We represent an entity with a rounded square symbol and define it using an entity specification consisting of entity name, definition, description, role in the business, key data elements, non-key data elements, events that use this entity, volumes, and global rules that are true for all occurrences of this entity. Here's a sample entity specification for an entity in my business. It's for an in-house seminar entity. As you can see, we can gather quite a lot of information about a specific entity. I just want to show an example in this overview section. Let me briefly define a relationship and what we gather in a specification for it. First, a definition. A relationship is a named association among the occurrences of two or more entities or two or more occurrences of one entity. Relationships result from business policy processing or situations. We represent a relationship with a diamond symbol. We can also support the relationship with a relationship specification. The relationship specification can contain relationship name, role in the business, cardinality between entities, connection rules, and events that create and/or delete this relationship. Here's a sample relationship specification for a relationship in my business. It's for an in-house buying relationship. As you can see, we can gather quite a lot of information about a relationship also. I just want to show an example in this overview section. Let me briefly define a data element and what we gather in a specification for it. A data element is a named characteristic, quality, or property which describes some aspect of a business entity and which takes on a value when associated with the occurrence of an entity. We define a data element using a data element specification containing data element name, parent entity, definition description, role in the business, events that use this data element, global rules that are true for all occurrences of this data element, and format, content, and domain. Here's a sample data element specification for a data element in my business. It's for the course, group, discount, price data element. As you can see, we can gather quite a lot of information about a specific data element also. I just want to show an example in this overview section. I'd like to finish this overview section with a note about how we can go about the procedure of information analysis. I call it progressive information modeling. Our goal is to create a business information specification, one that removes any old design characteristics. However, we can do this incrementally if necessary. I recommend we evaluate the need for intermediate information models on an event-by-event basis, and in a large organization, maybe also on a business area by business area basis. The cascading diagram on the screen shows a progression that we can use to develop a final information analysis specification. We can gather existing files to determine entities and relationships and retain any of their necessary design characteristics. We could record the existing files and their usage that we can use as a communication tool for business and user staff, and as an audit trail back to physical files. I don't really recommend we do an entity relationship model depicting the existing file structure though. Next, analyze and remove all design files and assign any data elements to business entities, and develop an information model and support specifications. In the best case scenario, where we have good documentation, or the business user knows the business policy and has knowledge of the concepts in this tutorial, we could immediately go to this step without performing the first step. We can then use the result of the last step to elicit new entities and relationships to support any new data requirements not supported in the existing files, and produce the new Business Information Specification. I've shown this outlined in red to indicate that this step produces the ultimate deliverable from this analysis tutorial. The last step in the cascading diagram shows we will use the new Business Information Specification to design the new files, be they databases or manual files, and add any necessary design entities and relationships to support the new design. We want to be careful not to spend too much effort studying any existing design files containing data that are not going to be used in the future. Let me use my own business here as an example to make my point. If we produce models for a training organization containing information for instructors, hotel facilities, and travel needs, etc., and then intend in the future business to do online video training only, we have wasted a lot of analysis effort, as those things will not be necessary in the new business. However, if we studied the seminar contents and support material, we have not wasted any analysis effort, as those things are aspects of the business and will be necessary regardless of any old or new design. I should also add here that it's not unusual to find no new data requirements once we've discovered the essential business data needs from the existing files. Note, when we move into the last step and identify processing requirements for the new design, we will need to identify any additional support files for that new design. In my business, for example, implementing online training may introduce entities for video supplies and support software, as well as new marketing data. Throughout this tutorial, I'm going to concentrate on producing an analysis-oriented model without design restrictions, but please realize that the concepts can be applied for modeling the entities and relationships of design files also.